Okay, here we go. I'm going to work the practice problems for this first section, the indefinite integral. And we're going to use these 4 rules. So I'm going to go back and forth. And practice problem on mine should be your number 1. Practice problem for me is your number 1 certify. So if you just go through this and you won't need to certify. You know, I mean, you won't need to practice. You can just go right to certify. But remember on certify, never accept a strike. If you do, it'll start you over. Always try a similar problem, okay? But the homework is for credit. So you got to do it because you want to get that. All right, so I'm going to just start. I'm going to put the rules down. So number 1 is the integral of -8/9 dx. All right, so what rule do we use? -8/9 is the derivative, and it is just a constant. It's just a number. There's no x in it, so we just increase it with respect to x. So that's -8/9 x, and we always have to put the plus c, okay? All right, and then, okay, that was rule 1. Question number 2, and my computer's, okay. Hang on. Okay, here we go. Sorry, my computer got stuck. So question number 2 is the big S 1/y plus 9y to the 7th dy. Well, remember, before I can use any of my rules, I always want to move the variable term up. So I'm going to rewrite that as the integral of 1y to the -1 plus 9y to the 7th dy. Okay, so I always just go ahead and try. When I add 1, what happens? My exponent is 0, so that tells me I can't use that rule 2 because I can't use it if the exponent's -1. And so I move when I get the -1 exponent, I bring my constant over, and it's just the ln of the variable. So that's 1 times the ln of y plus 9, and then I add 1 to the exponent, and I get y to the 8 divided by 8 plus c. And of course, you don't have to put that 1 right there. But no, you have to use the keypad for the ln and the keypad for the absolute value. Okay, all right, so question number 3 will be the integral of 4e to the 9x. And anytime you have an e, okay, that's always going to be rule 4, because there's your e. 4e to the 9x means 4e to the 9x, and you always just divide by the number in front of x. So 4e to the 9x is 4e to the 9x, and I divided by 9 plus c. So that's a pretty simple rule to use. All right, let's keep going. Question number 4 will be the integral of -3x to the -8 minus 6, okay, dx. All right, so here I don't have to rewrite because all my x's are up. So I'm going to just start applying my rules, okay? So this is rule 2. I'm going to add 1 to my exponent, and I get -3x to the -7 divided by -7 minus, and this is a constant, so I'm going to use rule 1. I'm just going to increase it by x, 6x plus c. And you can type it in just like that if you want to make that positive 3x to the -7 over 7 minus 6x plus c. That's fine. Either one of those will do. It's just however you like to do them. Okay, question number 5 is the integral of e to the x plus 3/5. Okay, dx. So I don't have to rewrite. This is a fraction, but there's no variable in the denominator. So this is rule 4, always with the e's. It's just going to be e to the 1x divided by 1, right? Plus, this is just a constant, so that's rule 1, 3/5 x plus c. And you don't have to divide by 1. You could just call it e to the x plus 3/5 x plus c. Either one of these will be fine for your answer, just whatever you're comfortable doing. Okay, let's go to the next one. In the integral of -8/9 x to the -1/2 minus 5 dx. Okay, I see fractions. You can't see anything. There's my problem. Okay, so this is, I don't have to rewrite anything. My x's are all up. And so this is going to be rule 2 when I have x to a power that's not -1. So I'm going to bring over my -8/9 x. And when I add 1, now remember, you can do it however you want to. You can say -1/2 plus 1 on your calculator. And get 0.5 and make it a fraction, 1/2. But I'll probably go -2 plus 1, that's positive 1/2. And we divide by 1/2, or I'm going to multiply it by 2/1. So I'll divide by 1/2. And see how messy it gets with that -8/9. So instead of doing it like that, I would probably say that's -8/9. X, my new exponent is 1/2, and whenever there's a fraction, instead of dividing by 1/2, I'll invert and multiply by 2/1. Okay, that makes it easier for me. Minus, don't forget about this guy, 5, it's just a constant, so that's rule 1, 5x plus c. So now I just multiply across, 8 times 2 is 16, 9 times 1 is 9, x to the 1/2 minus 5x plus c. And that's my answer. Okay, so don't let the fractions bother you. So question 7 is the integral of 7/x minus 2x to the -6/7 plus 7e to the x dx. All right, well, I do have an x in the denominator, so I'm going to rewrite this as 7x to the -1 minus 2x to the -6/7 plus 7e to the x dx. So that gives me, when I add 1, what happens? I get 0 divided by 0. So this is going to tell me, I bring my 7 over, and that's my ln of the absolute value of x minus 2x. And this is rule 2. That was rule 3. This is rule 2. When I add 1, when I add 7/7, I get 1/7. And I divide by 1/7 or multiply by 7/1. So that's just going to be 7/1 plus, and this is rule 4, 7e to the kx divided by k plus c. So my final answer, my antiderivative, is going to be 7 ln absolute value of x minus 14x to the 1/7 plus 7e to the x plus c. And remember, you have to use your keypad for the absolute value and for the ln. Okay, so let's go to the next one. 8. It's the integral of 15e to the t minus 8t dt. I don't like t's because they look like pluses. All right, so 15e to the t, everything's up. I don't have to rewrite. It's rule 4. And so that's going to be 15e to the t divided by 1 minus, and this is rule 2. There's an understood 1 on the exponent of t. So when I add 1, I get 8t squared divided by 2 plus c, and you can leave it like that. Or if you wanted to, you could just say 15e to the t minus 4t squared plus c. Either way, that you want to do it, however you feel comfortable is how I want you to do it, okay? Question number 9 is the integral of negative 4x to the 8 plus 5 over x plus 7 over x to the 6. So I do see that I have to rewrite several of these. Okay, so I'm going to rewrite. I'm not going to integrate this first term until I've got everybody ready to go. So I'll leave my integral sign, negative 4x to the 8 plus 5x to the negative 1, moving that up, plus 7x to the negative 6. Whenever I move these up, I just change the sign of the exponent. So now here I go. That exponent is not negative 1, so that's just rule 2. So my antiderivative is negative 4x. When I add 1 to 8, I get 9 divided by 9. Plus 5. When I add 1, I do get 0. So that's my rule 3. Okay, so that's 5 ln of the absolute value of x plus, here you go, 7. And this exponent isn't negative 1, so I can use rule 2 there. Add 1 to the exponent, and it's x to the negative 5 divided by negative 5 plus c. And I'm done. I'm just using my 4 rules over and over and over and over. Okay, so here, question number 9. The integral of negative 2 square root of x, we talked about this, minus 5 times the 4th root of x dx. Okay, so I've got radicals, and I've got to rewrite those radicals. So I think that we talked about sometimes when they give them to us in terms of radicals that we have to rewrite them, but I can't really find where I wrote that, so we're just going to write it again. Okay, all right, so the square root, when we rewrite this, I don't have to move anything up. I leave my integral sign. That's negative 2x to the 1/2. Square root is 1/2. Okay, and then minus 5, and that's x to the 4th root, so that's 1 over 4 dx. So for both of these are going to be rule 2. I'm going to add 1 to the exponent and divide. Okay, just don't get, so I can move my integral sign. Negative 2 is my constant, x. So when I add 1 to 1/2, what's my new exponent? 3 over 2, and I divide by 3 over 2, but I said I like it better to just multiply by 2 over 3. And be careful of that minus, because you're multiplying, not subtracting. So minus 5x, and when I add 1 to the exponent, 1/4 plus 4 over 4 is 5 over 4, and I divide by 5 over 4. You can do it on your calculator and get a fraction, or multiply by 4 over 5 plus c. Okay, so when I simplify, that's going to be negative 4/3 x to the 3/2 minus, you can call that negative 20 over 5. You can cancel that 5. 4x to the 5 over 4 plus c. Just know if it accepts it on the practice problems, it'll accept it on the certify, and it'll accept it on the test. So you just have to figure out what you like to do. I could call that negative 20 over 5. So you just have to decide. All right, so here's question 11. The integral of e to the negative 0.02x dx. Okay, all right, so the integral of e to the kx, remember, these are not hard. The integral of ce to the kx is ce to the kx divided by k. Well, the number in front of x is 1, so it's 1e to the kx divided by k. So it's e to the negative 0.02x divided by, whoops, I got 2 x's there, negative 0.02 plus c. And that answer is fine, okay? But I want to show you, maybe for later, okay, when we're plugging things into our calculator, remember this answer is absolutely fine, okay? But if I put 1 divided by negative 0.02, 1 divided by negative 0.02, it gives me negative 50. And so I might call that negative 50 e to the negative 0.02x plus c. Because when I'm plugging stuff into my calculator, I make fewer mistakes when I divide 50. Remember, I just said 1 divided by negative 0.02 to get that negative 50. So later when I'm putting things into my calculator, that's easier for me, okay? But it's up to you. It doesn't matter. As long as it's right on your Certify, it'll be right on your test. And remember, if you miss one on Certify, never accept a strike. Just try a similar problem. Let's look at question 12. This is the integral of 8e to the x minus 9x to the negative 6 minus 1 over 8 dx. Okay, all right, so you see that 1 over 8, you think it's a fraction, maybe I have to move something up, but you don't because there's no variable there. So we're ready to go. We're going to apply the rules. That's just rule 4, right? 8e to the x divided by 1 minus 9x, that's rule 2, add 1, what's my new exponent? Negative 5 divided by negative 5 minus, and that's rule 1, 1 over 8x plus c. And you can type it in just like that. Or if you wanted to make that a plus, you could, whatever you're comfortable with, they're the same. This is fine. And 8e to the x plus 9x to the negative 5 divided by 5 minus x over 8 plus c. It doesn't matter. Usually I go with the first one. The more I do, the more mistakes I can make. But it's totally up to you. Okay, so let's look at question number 13. And that's the integral of 3 over the 5th root of t minus 8 over t to the 4th dt. So I definitely have some rewrite steps to do, okay? So that is going to be 3t, and it's the 5th root, so it's 1/5 on the bottom, but when I bring it up, it becomes what? Negative 1/5, okay? Minus 8t to the negative 4 dt. So remember, when I'm rewriting, I leave my integral sign and my dt, so I don't get confused. Only I drop them when I start adding 1 and dividing. So I bring my constant. These are both rule 2, because my exponent is not negative 1. T, when I add 1 to 1/5, I get 4/5, and it's a fraction, so I divide by 4/5 or I multiply by 5 over 4, okay? Minus 8t, when I add 1, because I'm using rule 2 again, negative 4 plus 1 is negative 3 divided by negative 3 plus c. So I multiply 15/4 t to the 4 over 5 minus 8t to the negative 3 divided by negative 3 plus c. You can change those to a plus if you like. It's just a personal preference. So whatever you want to do. Okay. And then number 14 is exactly like that. They just give you 2 to try. So I'm going to call that 13 and 14. No sense in me working 2 of them when you've got that down. And so let's see. Okay. Number 15. Okay, I look at this and I go, And I go, wait a minute. I've had polynomials and stuff before, but that looks a little weird. And I don't have a product rule. So what do you have to do? You have to read the instructions. It said perform the indicated multiplication and then integrate. And then integrate. So what is the perform the indicated multiplication? Well, we distribute the x cubed through there because we need it to be a polynomial. So that's going to be 8x to the, what do you do when you multiply like basis? You add your exponents plus x to the third. Now I have a polynomial and I can use my rules on each term. And these are both just rule 2. So this is going to be 8x. My new exponent is 5 divided by 5 plus x. I add 1 to the exponent. 3 plus 1 is 4 divided by 4 plus c. And I'm done. Okay. And then 16. And there are a few of these at the end where you have to do something before you can integrate. So just be sure to read your directions. Okay, it says 5x plus 3 squared. And we don't have, we will in 6.2, but we don't have a chain rule or undoing a chain rule or anything like that. So we have to figure out what we're going to do. And it says perform the indicated multiplication and then integrate. Okay, so what's my multiplication? FOIL. So that is the integral of 5x plus 3 times 5x plus 3. Be very careful not to try to distribute the x because that won't work, right? You got to write it down twice and then FOIL it out. And then that gives me the integral of 25x squared plus 15x and plus 15x plus 9, okay? And now I just have a polynomial. And so I'm going to apply rule 2. So that is 25x, it's my new exponent, is 3 divided by 3 plus, that's also an x with a, not a -1 exponent, so that's rule 2. There's an understood 1 there, so when I add 1, I get 30x squared over 2 plus, and this is just a constant, so that's rule 1, 9x plus c. And you can simplify that middle term if you want, but you certainly don't have to. Okay? So just make sure you read the directions. All right, now, the other two are multiplication. So you're probably a little bit more familiar with those. So let's look. It says, simplify the quotient. And then integrate. So it's the integral of 4x to the 4th minus 5x cubed plus 3, and it's all over x to the 4th. Okay? All right, simplify the quotient. Now, we've been bringing this x up, but that causes for a lot of confusion when you distribute a negative exponent. So I'm going to divide all this out. That's 4x to the 4th over x to the 4th. It's like undoing a common denominator. So once I divide, and then I simplify. And remember, when we multiply like basis, we add our exponents. When we divide like basis, well, x to the 4th over x to the 4th just gives me 4 minus 5, and x cubed over x to the 4th, 3 minus 4 is -1, okay, plus, and then I just move this one up, 3x to the -4. And now I'm ready to apply my rules, okay? So 4 is just a constant, so that's rule 1. So that's going to be 4x, bring my constant. What happens when I add 1 to my exponent here? I get 0 divided by 0, so that's going to be rule 3. So it's going to be ln of the absolute value of x. Remember, you need your keypad for the ln and your keypad for the absolute value, plus 3x. And this exponent is not -1, so it's just rule 2. Add 1 to -4, and you get -3 divided by -3 plus c. And I would just leave that alone. Okay, all right, so that's it. That's it for the homework. And so what I want to show you is just one more of these, because if there's no coefficient on x to the 4th, that's when most people miss this. So let's just do a real quick 17 again. So if I had x to the 5th plus 3x to the 4th over, and then minus x to the 5th. Okay. All over x to the 5th. So it'd be the same thing. So we divide it. Do my divide. And then I simplify. X to the 5th over x to the 5th. This is where people miss it. That's a 1, and you have to put it's like a placeholder. Plus 3x. 4 minus 5, you subtract your exponents, minus 5, and then you bring this one up, x to the -5. And now you apply your rules. Don't forget about this 1. What's the antiderivative of 1? It's 1x, right? It's rule 1, and this is rule 3, because when I add 1 to the negative exponent, I get 0. So it's the ln of the absolute value of x minus 5x, and this is going to be rule 2, because that exponent's not -1. -5 plus 1 is -4, divided by -4 plus c. And that's it. And those are all the problems, and that's all the problems from 6.1, or not 6.1 all the time. Yes, 6.1, it's integration, using all your formulas, and this is the most important section we'll do because everything is based on that. So I hope this helps. You got to let me know. You got to communicate with me, and you know, sorry. Yeah, let me know. I worked you know, we're all new at this. So if you have suggestions, I'll take them. It's something I've tried to teach using a chalkboard, and it just doesn't seem to work as well. But I'm willing to try anything. If you've seen other teachers do something that you like better, I'm an old dog, but I can learn new tricks, and I like them. So, okay. All right. So good luck. Keep me posted. Email me if you have questions. Bye.